Welcome to differential equations discussion. So variable separable is our topic today. Uh, Variable separable is the first technique for finding the solution for a differential equation. But this only applies to first order equations and only in certain cases. So if you have the form dx over dt is equals to some function of x and then some function of t. Now that is a variable separable equation because you have a derivatives on the left side and then you have the function of x and then a function of t on the right side. So for example, the equation is dx over dt is equals to x squared times t. So you have some derivatives in the left side and then a function of x and a function of t. Another example is dx over dt is equals to t to the 1/2 times the square root of x. You have a function of t and then you have some function of x and then the derivatives on the left side. But you cannot say dx over dt is equals to the square root of x to the power of t because the terms x to the power of t cannot be separated. So as you can see, we can only apply variable separable in certain cases. So let's try to do some example. So first is the example is 3 dx over dt is equals to 2x. Now before we solve this equation, we should know the step of how to separate how to solve a variable separable equation. So the step in getting the solution is number 1 is you should verify or validate if dx over dt is equals to function of x times function of t. And then so you should verify if the equation is in the form of dx over dt is equals to function of x times function of t. And then next step is you rewrite the equation into the form of dx is equals to function of x times function of t dt. So now after rewriting the equation and combine the terms that is of like terms, so the following like terms is x, so the equation now becomes 1 over function of x dx is equals to the function of t dt. So now we have both like terms in the equation, so we can integrate both sides. So integrate both sides. So now 1 over function of x dx is equals to function of t dt. And then after you integrate both sides, you should obtain or you should get the function of x is equals to function of t plus c. So note that the capital letter F and capital letter G denotes only for the function that we got after integration. So next step is try to solve for x in terms of t. So that's the steps in finding the solution for a variable separable equation. So step 1 is verify dx over dt is equals to function of x times function of t, and then rewrite the following equation into dx is equals to function of x times function of t dt, and then combine the like terms. 1 over function of x times dx is equals to function of t dt, and then after you have combined the like terms, you integrate both sides and you should get the function 1 over function of x dx is equals to the integration of function of t dt. And then after you integrate, you should obtain the following: f of x is equals to g of t plus c, or the function of x is equals to function of t plus c. And then try to solve for the x in terms of t. So let's say, for example, example number 1. dy is equals to 2x plus sine 3x dx. So now the equation is now in the form, or it is in the step 3, because we know that these are in the same terms. So dy is equals to 2x plus sine 3x dx. So it is now in the step 3. So we know that the step 4 is we have to integrate both sides. So integrating both sides, dy is equals to integral of 2x plus sine 3x dx. So now integration of dy is equals to y, then integration of 2x plus sine 3x is equals to x squared minus the 1/3 cosine 3x plus c. So that becomes your general solution. This is now your general solution. And then moving on, another example, example number 2. Example number 2 is 3 dx over dt is equals to 2x, as we have shown, as we have written last time. So 3 dx over dt is equals to 2x. So we have to do some manipulation to get in the form of step 3. So step 2 is 3 dx is equals to 2x times dt, and then combining the like terms, the equation now becomes 3 over 2x dx is equals to dt. And then integrating both sides for step 4. So integrating both sides, so 3 halves times 1 over x dx is equals to integral of dt. Now the integral of 3 halves times 1 over x dx is equals to 3 halves times the natural log of x is equals to t plus c. So the integral of dt is equals to t plus c. and then transpose the constant into the right side. So the equation now becomes natural log of x is equals to the 2/3 t plus c. So this is now in the step 5. We are now in the step 5. So the next step is we try to solve the x in terms of t. So the equation now becomes, so how do we solve that? We multiplied it by e. So e to the ln x is equals to the e 2/3 t plus c. But we know that this equation is same to 2/3 t times e to the c. And then we know that e to the c is c. Then the equation e to the ln x is equals to x is equals to e to the c is c, and then e to the 2/3 t e to the 2/3 t. Now you have the general solution for the given example. Another example is third example is x plus 1 t squared plus 1 is equals to t dx over dt. So now we try to manipulate the following equation to get that we multiply or we transpose the t into the other side. So the following equation becomes dx over dt is equals to x plus 1 times t squared plus 1 times 1 over p. So now we have the function of x and then the function of t. So after that we should combine the like terms. The equation now becomes 1 over x plus 1 dx is equals to t squared plus 1 over t dt. So now we have to integrate both sides because we are now in the step 3 and we have combined all the like terms, and then so integrating both sides. So the integral, so let me try to solve the equation on the left side. So 1 over x plus 1 dx. So you know that 1 over u du is equals to the natural log of u. So this becomes natural log of x plus 1. So the other term, the other equation is equals to t squared plus 1 over 2. So after we do some manipulation in algebra, so we get that t squared over t plus 1 over t dt. So now we have simplified the equation. So now cancels out, this becomes integral of t plus 1 over t dt. And you know that the integral of a variable is equals to 1/2 t squared plus 1 over t is equals to ln t plus c. Note that we have only one constant because we are in the first order. So now, after combining the solution that we got or the answers that we got after integrating, so the equation becomes x plus 1 is equals to 1/2 t squared plus ln t plus c. So eliminating the natural log, we have to multiply it by e. So thus the equation becomes e to the natural log of x plus 1 is equals to e to the 1/2 t squared plus natural log of t plus c. So the equation now, x plus 1 is equals to, you know that this term e to the t squared times e to the ln t times e to the c is same in this equation. So now x plus 1 is equals to e to the c is equals to the c, and then e to the ln t is equals to t, and then carried out by e to the 1/2 t squared. Next thing is transpose the constant into the other side. So the equation becomes c times t times e to the 1/2 t squared minus 1. That's your general solution. So next example is e to t x prime plus e to the t is equals to 1. So this x prime is, we know that this is in the e to the 2t dx over dt plus e to the t is equals to 1. So after we have done some manipulation, the equation becomes e to the 2t dx over dt is equals to 1 minus e to the t. And then combining our in the step, this is in the step 1. So in step 2, dx is equals to dx over dt is equals to 1 minus e to the t over e to the 2t. So in step 2 is dx is equals to 1 minus et over e to the 2t times dt. So we have combined the like terms. We are now proceeding for the step 4. So integrating both sides, dx is equals to the integral of 1 minus e to the t over e to the 2t dt. So integral of dx is equals to x, and then the integral of 1 minus e to the t over e to the 2t dt. So we have to do some math here. The equation now becomes 1 over e to the 2t minus e to the t over e to the 2t dt. So this would be cancels out. The equation becomes e to the negative 2t minus e to the negative t dt. But you know that EU du the integral of EU is equals to EU du. So let u is equals to negative 2e, and then the du is equals to negative 2 dt, and then the dt becomes negative 1/2 du. The other side is let u is equals to negative t, and then du is equals to negative dt, and then the dt is equals to negative du. So now we have EU times negative 1/2 du. The other side is EU times negative du. So now integrating that, we get negative 1/2 EU plus EU plus C. So we know that the U is negative 2t, so we arrive at negative 1/2 e to the negative 2t plus e to the negative t plus c. So this is equals to x. So now the solution is x, or the general solution is x is equals to e to the negative t minus 1/2 e to the negative 2t plus c. So this is now your general solution. So this is your general solution. And then that's it. Thank you for listening. Hope you have learned the variable separable equation. A first technique for determining the solution of a differential equation.